Hi, welcome to my video on find to the nearest tenth of a degree of rotation on any circle with 0, center. 0, center. Most trig that you do, the center of the circle will be 0, but it don't have to be. Let's look at the first question. Find to the nearest tenth of a degree the value of theta on the interval 0 less than or equal to theta less than 360. That means the value of theta has to be equal to 0 or in between 0 and 360. So that's what this interval means. So that means there's no values of theta greater than 360 like 400 or 700 or etc. There's no negatives. So it's just got to be between 0 and 360 positive, as you can see. Let's do an example. We have a point, -3, 4, lies on the terminal arm of theta. So we have to find theta. Oops, let's mark the stroke here on theta. So what we could do is, if we draw a circle, I always like to draw a diagram for myself to make sure. The point is -3, 4, so x is -3 and y is 4, so let's pretend that that point is right there. Don't have to be exact on the. We have a terminal arm going out through that point, and theta, there's a circle that will go through that point. There it is. And theta is the rotation from the initial arm right around to that point. So we want to find the value of theta. So what we do, we drop a perpendicular to the x-axis, but what we need only is just a reference angle. So if we need the reference angle, that means we have x is -3 and y is 4. So the reference angle, notice the reference angle, this is the x and this is the y. So y over x is tan. So the tan of theta is the y over the x, which is 4 over -3, which is -4/3. That's if we wanted to find the value of theta to the nearest decimal. But what happens, you don't have enough trig in your background to really answer this question yet. You got to do another course in trig to get this answer from the calculator. So what I do, I'll say the tan of the reference angle. And the reference angle is always the angle. So the reference angle is always the angle between 0 and 90. So the reference angle, in a sense, it could be the angle that's in the first quadrant. And that means that if it's in the first quadrant, then it's a positive ratio as 4/3. So notice this is the y over the x. So what we need to do is pick up our calculator and turn on the calculator, and we do inverse tan of 4 division 3. And that will give us 53.1. 53.1. So what happens? We have the reference angle is tan to the -1 of 4/3. And that means the reference angle is 53.1. So if that's 53.1, then theta is the rotation from here to here. So all the way is 180. So therefore theta is going to be 180, which is this rotation right here, minus the reference angle, which is 53.1. And that gives us 126.9 degrees as the rotation. So again, I'm looking at it from the point of view of the reference angle, and the reference angle is always positive. So therefore, when I do the any trig ratio in relation to the reference angle, I always have a positive fraction. And then the calculator will give me an answer between 0 and 90. And then I can work or manipulate the angle as 180 minus, 180 plus, or 360. You'll see that as I go on. So tan is we have it worked out. So theta to the nearest tenth of a degree is 126.9. Okay, let's do another one. Cos theta is a negative 12 over 13 in quadrant 3. Okay, let's go to quadrant 3. Notice, let's get back to this one for a second. Notice I didn't need the radius. I already have the coordinates of the point. Remember, the coordinates of this point, that's the x, and that's the y. So because I got x and y, I can use tan. But if I did work out the radius, I could use cos and sine and get the same answers. But because I have x and y, tan is the y over the x, so I didn't need to get the radius. So let's go back to B. Cos theta is a negative 12 over 13 in quadrant 3. So we draw a circle. Let's extend this down and out. This is x and y. And notice that we're in quadrant 3, so theta is the rotation all the way around. Here we go. Theta is this rotation till we get somewhere in quadrant. I'm not concerned exactly where I want to be. So let's stop here and draw my terminal arm out through. So that's the initial arm, which is this one, rotated right on around till it stops right here. And that means that if cos theta is negative 12 over 13, that means that I want the reference angle. So if I can get the reference angle here, right here, I can go 180 plus the reference and I'll get that rotation. So to get the reference angle, I'm going to say the cos of the reference angle is 12 over 13. Remember, when you want to get the reference angle, the fraction or the decimal or whatever you have should be positive. So therefore we have the reference angle is cos to the negative 1, and that'll appear on the calculator that I'm going to do now. Here we go. Here's the calculator. I got it on. So I have to go inverse cos, because I'm looking for the angle, of 12 division 13, close it off with a bracket, and I'll get 22.6 to the nearest tenth, 22.6. So 22.6. Okay. Now, the rotation of theta is going to be 180. Notice 180, 180 plus the reference. So theta is going to be 100. I got a 22.6, so I got 202.6. If you add them up correctly, 202, so 0.680, yep, 202.6. So theta is the rotation all the way around right to there. Again, using the math, and there's a unit on solving right triangles in trig, and in that unit we practice how to get the measure of the angle by doing second function in your calculator. Now we have a practice another. So pause the video and work these out. So when you work these out and you get the right answer, then you know what you're doing. Here we go. Find to the nearest tenth of a degree the value of theta on the interval. Again, the interval equal to 0 but not equal to 360, and between 0 and 360. So we have the point -2, -5. So that's the x, that's the y, and the point is, let's draw a circle. So the point is x is -2, y is -5. Let's pretend that that point is right there. And this point is -2, -5. The terminal arm goes out to that point. the rotation, there's the initial arm right there. So this arm is rotating all the way around, right over here, till you hit that point. And so this is theta. We're going to find that value. So if we drop a right triangle to the x-axis, x is -2, y is -5, and the reference angle is right there. Reference angle is always in the corner of the right triangle between the terminal arm and the x-axis. So what we have, because we have x and y, that's the x and that's the y, I'm going to use tan. So the tan of theta is the y over the x. So it's the y is -5, x is -2, so that's 5/2. Already positive, that's good. But if I do the tan of the reference angle, it's positive. So if I work this out right now by doing theta equals tan to the -1 of 5/2, I will get the reference angle. Because it's positive, automatically theta is the reference angle. So the reference angle is going to be tan to the -1 of 5/2. And we put our calculator here. And we clear it. Oh, I pressed on that. So inverse tan of 5 division 2, and we get 68.2 degrees. 68.1, but this is 5 or greater, so we'll add 1. 68.2. So the reference angle is 68.2 degrees. And again, this question, theta is 180 plus the reference. So it's 180 plus the reference. And we add that on, we get 0.2. 8 added on to 0 is 8. 6 added on to 8 is 4, so 248. So theta is 248 degrees rotation from this point right here. And we have another one to do, so don't forget, if you want, pause the video and work out your answer first. Good way to do it. Sine is 5/18 in quadrant 2. We want to find the value of theta in quadrant 2. So we'll draw the diagram in quadrant 2. We do the rotation. We're going to do it in terms of a circle. And sine is 5/18. 5/18 is positive. So we'll go already positive. So we'll just say we're going to get the reference angle. 5/18. So the reference angle is sine to the -1, 5 divided by 18. And before I work that out, I just want to draw this diagram. We're in quadrant 2. So theta is the rotation again. This is the terminal arm. We rotate all the way up. And I'm not concerned how far in here I go. I just stop here. And there's the terminal arm going out through there, rotating. And the reference angle is right here in this part. If we draw a right triangle to the x-axis, perpendicular to the x-axis, then 5, notice that sine is the x over the r. So x is 5 and the radius is 18. The radius is the hypotenuse. And notice we do not need the other side. We can work with the sine. And so we're looking for the reference angle. And I put the calculator here. Here we go. I'm going to clear that now. So inverse sine of 5 division 18. And we get 16.1 to the nearest tenth. This is less than 5, so we don't change the 1. 16.1. So the reference angle is 16.1. Now, all the way around right to here is 90, 180. But because this is a reference angle right here, I have to take that off the 180. So theta is 180 degrees minus the reference. And that leaves, if you subtract correctly with your calculator or with your head, you'll get 163.9. That's the rotation of theta from here to here. Okay, let's continue. The more you do, the better you get. Don't forget, pause your video and work these answers out. Now, we have another one here. Find to the nearest 10th degree the value of theta on the interval again between 0 and 360. But notice this time we're not told what quadrant to go into. So I got to say to myself, where do I put tan? So I recall that ASTC starts in quadrant 1, all, sine, tan, cos. So because I'm not told where tan is going to be positive, I have to say to myself, ASTC, tan is positive in 1 and 3. So that means I have to put tan in quadrant 1 and tan in quadrant 3. So I'll draw a circle. So I draw a terminal arm in 1, and I draw a terminal arm in 3. So the rotation for theta is from here to here for quadrant 1, and for quadrant 3 the rotation is here. Now you could use Castro, C-A-S-T, but when you use C-A-S-T, you got to start in quadrant 4, C-A-S-T. I'd rather A-S-T-C. Or another way, remember tan is the y over the x. And y, if you put the y over the x and you get a positive fraction, that means the two signs got to be the same, which is in quadrant 1, x is plus, y is plus, or in quadrant 3, x is negative and y is negative. In any case, let's have a look and work out the tan of theta is 2/5. So the tan of the reference angle, mark that, reference angle is 2/5. It's already positive, but I'm finding the reference angle. So the reference angle is tan to the -1 of the 2/5. And pick up our calculator. There it is. Got it cleared. So inverse tan of 2 division 5 gives us 21.8 to the nearest degree. 21.8 is the reference angle. So if this is the reference angle right here, 21.8, so that's automatic. Theta is 21.8. And over here in this diagram, the reference angle is right here, 21.8. So in quadrant 3, it's 180 plus that. So it's 180 plus 21.8. And that gives us 201.8. So the two answers for, and if you want to check that, just watch this also. If you want to check it, if you take 21.8 and plug it in, you should get 2/5, which is around 0.4. So 21.8. So let's take the tan of 21.8 should be around decimal 4. Oh, pretty good. Decimal 3999 is 0.4. Or we could do the tan, and again we're checking, tan of 201.8. 201.8 should give us the same value. And I know I'm right. I just checked myself. So plugging the answer back into here should give us 2 divided by 5. is 0.4. So I know I have the two answers right. And another one to do. Let's work with this one. Find to the nearest degree alpha on the same interval. But this time we have a reciprocal ratio. We don't want a reciprocal ratio, it's not on the calculator, but the reciprocal of cosecant begins with C is S. So the sine of alpha is 7/10, but is negative. Now, we notice that this is negative, so if I want the reference angle, I'll make the fraction positive 7/10. And the reference angle is sine to the -1, 7 divided by 10. So the reference angle, pick up the calculator, we got it cleared. So it's inverse sine of 7 division 10. And I have 44.4 to the nearest tenth. 44.4. So the reference angle is 44.4. Now that I have the reference angle, now I got to decide where cosecant is negative, where sine is negative. So I do add sugar to coffee. And sine is all, so it's in quadrant 1, which is right here. And sine is positive in quadrant 2. So this is all sine, tan, cos. So sine is positive automatically in first quadrant and in the second. So we draw the two terminal arms. So the rotation is right there. So the reference angle is 44.1 because the reference angle is between the terminal arm and the x-axis. And alpha, and alpha here starts and rotates right over to here. And the reference angle is between the terminal arm and the x-axis, 44.4. First quadrant, alpha is the reference angle, 44.4 degrees. And alpha here is in the second quadrant, so alpha is 180, come back 44.4, subtract. And that gives me if I come back, if I subtract, I get 135.6. 135.6. But what happens if after all that I have to go where I'm going where, guess what? I just noticed, and it's a mistake, but it's a good mistake, I got to look up where sine is negative. So that's positive in 1 and 2. So it's in 3 and 4. Oh, that's almost a mistake then. Almost. It's in 3 and it's in 4. So alpha is this rotation with the reference angle. And alpha is this rotation. So the reference angle is between the terminal arm and the x-axis right here. Between the terminal arm and the x-axis. So in this quadrant, you have alpha is 180 plus 44.4. So what a mistake. I almost messed it up completely, but I just happened to notice that this is negative. And the alpha here is going to be, again, 360 is all the way around and come back 44.4. And I apologize, I made a mistake, but we all make mistakes and we check ourselves. I was going by where this was 7/10. It's not. I got to go by what it is initially. where sine is negative or cosecant is negative. So that's positive here and is negative here for sine. So it's quadrant 3 out of 4. Okay, caught myself on that mistake. That's good. Oh, let's go back to there again. Let's go back and check. Just check for a second. What about if I left 44.4 there? Remember what I said? If you plug the 44.4 back into here, then you should get a negative 7 over 10. So let's try it. 44.4. So the sine of 44.4 0.69, almost a 7, but it's not negative. So by checking myself, I would have discovered that 44.4 is in the first quadrant, the sign is positive, so I have a mistake. Then I realized I'm not in the right quadrants. So now I go back and check with 224.4. So we check, clear it, the sine of 224.4 should give me negative 0.69. That's a negative 7. So these two answers are correct. Just checking out. Okay, now I have a sort of a different question here, but it sums most things up that we've done. This question is extremely important to understand and how it works out. We got always the center of the circle. This is a circle symbol, a circle with a dot in it. The center of the circle is 0, 0 right here. So we have this circle. I have different information on it. P lies on the terminal arm of theta. So P, this point, and this point is 512, lies on the terminal arm of theta. So theta is this rotation right now from here to here. Okay, so that's theta. So P lies on the terminal arm of this rotation. Remember, the rotation starts, this is the initial arm, and it swings all the way up till it hits here, passing through the point 512. So I'm asking you to find the radius of the circle. So if we drop a perpendicular to the x-axis, x is 5, y is 12, and we want to find a radius. So we have r squared is x squared plus y squared. And the radius r squared, x is 5, y is 12. Let's go up right here. So that means r squared is 25 plus 12 squared is 144. R squared is 169. So the square root of r squared plus minus the square root of 169. R is plus or minus 13. And because we have a radius, then r is 13. So we'll put 13 in the diagram. Now, the rotation is on this point. So because the radius of the circle right here is 5 units, 13 units, be careful, which is right here. I got 13 right there, so I don't need it right there. There's 13 radius. That means the radius of the circle are equal. So that means that's the 13 right there. This is the 13 here. This is the 13 here. And this is 13. That means that all radii are equal. That means that this is a 13 out here. So that's 13. Then this is a 0. If we go up here, x is 0. Y is 13 because it's the radius of a circle. If we go out here, we get this point. Well, I'll just look at points A, B, and C, and D first. So this is x is negative 13 here, and y is 0. And when we come down here, the x is 0, and the y value is negative 13. So A is 13, 0. B is 0, 13. and C is negative 13, 0, and D is 0, negative 13. So notice the x's, 13, negative 13, the y's are zeros. When you move up and down on the y-axis, the x's are zeros, y is 13 up and 13 down. So this is the point. The point 13, 0 is moving around on this circle. And as that point moves around, then the coordinates of x and y change as it rotates. So let's get the value of the measure of the angle AOP, angle AOP, this angle. So this angle right here is, we can get that angle by using sine, cos, or tan. So you can use cos of that angle, whatever we want to call it. Let's say the reference angle. We could use the cos is adjacent over hypotenuse, or the x over the r, which is 5 over 13. We could use sine of the reference angle. Sine is opposite over hypotenuse, or the y, which is 12 over 13. Or we could use tan of the reference. Tan is the y over the x, or opposite over adjacent. So y over x is 12 over 5. So all of these, no matter which one you use, will give you the same size reference angle. And we'll take it to the nearest degree instead of to the nearest 10. So let's do inverse. Let's do this one. Inverse cos of, that's a 5 over 13. Let's see what we get. Turn our calculator on. Inverse cos of, what did I say? 5 division 13. And to the nearest degree, I get 67. So let's 67. So let's work that out for sine to see what happens. So sine, clear, inverse sine. Sine is 12 division 13. And the same angle, 67 to the nearest degree. Or we can clear it and do tan, inverse tan of 12 division 5 gives you the same angle, 67. So the reference angle in the first quadrant is 67, no matter which one of these you use. Is cos, sine, or tan. So that means this angle right here is 67. That's your reference angle in that quadrant, because it's between the terminal arm and the x-axis. So if that be the case, in this quadrant here, if I drop that perpendicular down here, that perpendicular comes on down and goes to there. So the reference angle in this quadrant is going to be the same if all reference angles are the same and all triangles are congruent. Remember, that's a negative 5, opposite to this one. The y is 12 going up. So the triangles are congruent, only they got negatives and positives. And so this one is a negative 12 for the y. That's 12 up, that's 12 down. And if you drop this one on down through, this is 5, this is negative 12, and that's 13. So all these triangles are congruent if you ignore the pluses and the minuses. But all the reference angles are the same, 67. 67. So what is AT? AT is this arc right here. So that's 180 minus 67. So it's 180 minus 67, which is 113 degrees. And AW is all the way over to here. So AW arc is 180 plus the reference angle of 67. So 180 plus 67, which is 247. And AR is all the way around to here, right? So we can go because we have a reference angle, we can go to 360 and come back. So it's 360 degrees, subtract 67. And that leaves 267, that was 293. So these are the other rotations. So if you took this point, 13, 0, and rotated 113 degrees, you would get the coordinates of this point. If you rotate it 247, you get the coordinates of W. And if you rotate it 293 degrees, you would get the coordinates of R. And speaking of the coordinates, because the reference angles are all equal, that means that these points are the same. So the X here is, because you moved across here, that's -5. And the Y is the same height, 12. So when you move over here, it's the same coordinates except the opposite sign. So notice moving it here, the X is negative, but the Y is the same height. When you move down through here, what you have is the X is the same, and the Y is the opposite. So moving it on down, -5 is the same, X is the same, Y changes. When you move it, either you move down here, what happens? If you move down from this one, the X is the same, but the Y changes. If you move from here to here, the X changes, but the Y doesn't. So moving from W to R on this horizontal line, the X goes from a -5 to a +5, but the Y stays the same, -12, -12. So there are the coordinates. T is -5, 12. W is -5, -12. And R is 5, -12. So that sums up the trig that you learned so far. It's a good review on all the trig concepts. And notice, because you have the same reference angles, then all these points are going to have the same coordinates except plus and minuses and the radius of the circle. But the rotations are depending on what quadrant you end up in. And I hope you enjoyed that video, especially the last sheet there that sums up a lot of trig. If you like my video, click the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.